and I almost fell. Okay, this water is moving fast. If I was not wearing hiking boots, well, wading boots, I would have twisted my ankle just now. Pretty bad. I mean, I was in a little bit of pain for that, but oh well. Okay. So the point here is you're just going down and stabbing the creek and then coming back up. Okay, this gives you, if I had a dedicated device, I would do this under a certain frame of, I'd be timing it specifically, but since I don't have the specific sampler that has the chart for how fast you're supposed to do it, you can pretty much just guesstimate. I mean, as long as it doesn't overflow and as long as the sample like barely collects anything, you're good to go. Okay, so now our next spot, we add 32 to our previous location. So we were at 28. Now we're going to go up to, well, let's do it slowly. Okay, so we're adding 32. What's 28 plus 2? 30. Well, now we add another 30. That brings us up to 60. Simple math. Okay, so about here. Okay. You just touch the bottom and come back up. Just one thing to make sure is that you don't pause as you hit the bottom. Because whenever you hit the bottom, you stir up debris. If you stay there and pause there, you collect debris. Yeah. And it helps keep you consistent. That was a bad sample. There we go. That was a close one. I almost lost that one. Awesome. Oh well. Okay. Now 92. $92. Now I might have to end up triplicating it again because I need a liter of this. Last one, 92. Now that part obviously has the highest flow rate. I can tell because it almost knocks my feet out from underneath me. Okay, so 92 plus 32. 92. Okay, so 30 plus 90 equals there. So we need to be at 114. Let me double check this. 20. Yeah, okay. 124. Always double check your work. So this is difficult. I have to make a judgment call for this. I have to change it a little bit. I have to go out further. Okay. As you can see, this is not nothing's ever going to be perfect. That's just a sad fact about geology. This is the natural world we're dealing with. This is not an isolated event. Things happen. But we do take measures to try to get it as exact as possible. One of that is by collecting a representative sample. Okay, so let me see how much water I obtained here. I have about half a liter, so I'm going to go ahead and do it again. This time I'm going to work my way back. Because you need at least a liter to sample with. I don't agree with this number, but this is the USGS manual that we're talking about here. These are standards. And unfortunately, it's something you have to put up with as a scientist to have credible data. It has to be done via a standard. No matter how old that standard is or how much you don't agree with it, you just have to do it. '92. Now this should produce a liter for me. And what I'm seeing here is that the river just picked up a bit. This is natural. Rivers change flow rates all the time. So it's good that I doubled back and redid this. 92, 60. Now, the reason why I don't just discard this data because the flow rate changed is because my flow meter will tell me an average of the flow variation here. Normally, I mean, that is kind of a heart for concern, but this stuff has been going on for years. We can guesstimate, we can account for things that would normally go wrong. I mean, if this was a newer science, maybe this wouldn't be the case. But whenever I go to do my flow meter, I do it over a span of 40 seconds. And that'll give me a pretty good indication of the variation in the stream and give me an average. Okay, we got plenty of water now. Now I'm gonna just toss that up there. We're done with it. Now, here comes the fun part. Hopefully I don't lose this case down the river. That would be bad. Okay, missed the flow meter. Oh. There's another spot where I would have just twisted my ankle if I wasn't wearing proper gear. Oh, let me tell you, that was painful. Okay, so right now, I'm writing the distances to depth. Okay, and I do this with my flow meter. It has graduations on it. Unfortunately, to get the depth, you have to be pointing this the wrong way. That's very unfortunate. I might see if I could get this twisted around sometime to the other side. No, I can't do that. Can't do that. This, oh, it's taped on. The tape needs moved to the other side. Darn. Okay, anyway. So now I'm going to get depth. I'm at 28 inches. It is 0.62. 0.62 feet. Okay. So you can see that. This has graduations and a tenths of foots. And then it also has fifths. So I got a sixth, and it was right here, so that's 0.62. I could go ahead and go graduation down lower, but I don't want to I don't trust my eyes in this occasion, since it's flowing water. There's a meniscus involved in whatever I do. So pull out my notebook. Okay, I wish this was waterproof. It should be waterproof, but it's not. Okay, so 28. The depth is 0.62. Okay, at 60, where I surveyed it, see, look at this. This is a problem. I don't exactly know how to accommodate for that, but I'm going to say, give an educated guess, at about a 1.04 feet. $60. 92. Ugh. Fighting the current. The current is strong with this one. Let me see if I can get an average here. See, look at that. That's difficult to determine. So this says about 1 foot. I'm going to just go with 1 foot. I can't get any better than that. So this reduces my sig figs from 3 digits down to 1. So I can't get an accurate reading off of this creek here. That's unfortunate, but it is what it is. I mean, you've seen it. There's a problem. Okay, so then at 124, I would say the average of that is probably 0.9 feet. You see, 0.9 from 3 sig figs down to 1. It's just, it is what it is. If I had gotten a flatter one and made it parallel to the stream, that would give me better results, but I'm using the instrument that I have. Whenever I come out here next time, I'll probably have a better measuring device. I wasn't expecting that, because this is the fastest I've seen the stream move. So, okay. So now I got to figure out what is 6/10 of 62, and that's how far deep into the water I have to put my flow meter to get an accurate reading according to the USGS guidelines. Okay, so 0.6 times 6, that's 0.32 feet. So I have to barely put this into the water in order to get a true reading. So I'm going to put it down to that mark. I'm going to collect my data. But first, before I collect my data, to twist it around, and I have to reset my speed. Reset. Done. Okay. Now let me put this back in my pocket so it don't get wet. Okay. Now we're going to count to 40. 40 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. So it says 0.81. I'm not really satisfied with that number, to be honest with you. I feel it's going faster, but that's what the data tells me, so that's what I'm going to have to go with. Now I suspect the middle is considerably faster, but we'll see what happens. Okay, so the depth here, well, this is easy. I have to go down to 6/10 of a foot. Okay, so what's 6/10 of a foot? It's 6/10 of a foot. Let me reset my data here. Okay, at 60 mark, count again, 40 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 1.7. That was pretty good. I still think that's a little bit low, but I mean it's about, it's triple the speed of the last section of the creek that I was at, and that's actually still low. I think this is still faster. I think it's going to get faster as we go down. Okay, so next spot. Reset it. Come on. Oh, let me see how much time I have left in the day. I have, I think, an hour. Maybe an hour and 30 minutes. Okay. Let's get this done. Okay. So this was about a foot as well, if I remember correctly. Yeah, it was exactly round about 1 foot. Because remember, we couldn't get an exact reading on that because of the surface tension of the water. Okay. So again, okay, we've reset it. That's good. Now, put it in the direction of the creek. Find 92, where we surveyed it. And we're going down to 6th. 6th is right here. Okay. Oh, that almost ripped it out of my hands. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40. 262. Now that's about what I was expecting it to be. Okay. Next one is also about a foot. Let's reset this. Now see, the reason why, let me give a brief survey of this creek. There is, I mean, you can't really see it because there is boulders right here, but there is a slight slant here. And the reason for this slant, well, if that wasn't there, it'd be much better. But the reason for the slant here, you see it slanting sort of this way, is that we are in the middle of a bend. Like I said, this is not an ideal situation. I would have wanted to be down there, about where there, but that's still, you have rapids right there that would mess up the data as well. And above that rapid is too deep for me to wade. Okay, like this was 2.6, and it's about